Hello, I want to take a moment and go over this exam that you just took today. And I want you to grade your exam and then upload it to Canvas for this assignment. The first question says, the profit in tens of dollars from selling X hundred boxes of Christmas lights is given by P of X equals negative X cubed plus 10X squared minus 12X. So answer the following questions. Find the number of Christmas lights that should be sold to produce the maximum profit. So when we're trying to figure out what maximizes or minimizes something, we need to find the derivative and find the critical values. Critical values occur when the derivative is equal to 0 or where it's undefined. So looking at the derivative of our profit function, we have P prime of X is equal to, well, the derivative of negative X cubed is negative 3X squared, plus the derivative of 10X squared is 20X, minus the derivative of 12X is 12. So we want to find when P prime of X is equal to 0. So I'm looking at when is negative 3X squared plus 20X minus 12 equal to 0. So this actually factors as negative 3X plus 2 all times X minus 6 equals 0. If you didn't see that, then you could use the quadratic formula or use the AC method to factor. Now set this equal, each factor equal to 0, and solve for x. We have negative 3x plus 2 equals 0, and we have x minus 6 equal to 0. Solving for x, we have negative 3x equals negative 2, and then x is equal to 2/3. Solving when x minus 6 equals to 0, we get x is equal to 6. We need to see if the critical values, or critical value is a max or a min. And so we can test values on each side of our critical number into the derivative function to see if the function is increasing or decreasing. So let's choose a number to the left of 2/3. 0 falls to the left of 2/3. Plugging that into my derivative function, I get back that P prime of 0 is equal to negative 12. So my function is decreasing on the left of 2/3. Choose a number between 2/3 and 6. So how about P prime of 1? This gives us negative 3 plus 20 minus 12. This number is greater than 0, so I know it's increasing. So 2/3 is a minimum, and I'm trying to maximize this profit. So let's plug in a value which is greater than 6. Plugging in 7 into this function, we get negative 3 times 49, which is negative 147, plus 20 times 7, which is 140, minus 12. This is a number that is smaller than 0, so our function is decreasing on the left of 6. So something increasing and then decreasing, I can see that x equals 6 is a maximum. It tells us back in the original problem that x is in hundreds of boxes of Christmas lights. So in order to maximize profit, we need to sell 6 times 100, or 600 Christmas lights. So part B of this question wanted to know what is the maximum profit. So in order to find that maximum profit, we need to figure out what P of 6 is. So we want to go back into the original problem function and plug in 6. So we have negative parentheses 6 quantity cubed plus 10 all times 6 minus 12 times 6. So this is equal to, so cubing 6, we get 216 with a negative in front, so we have negative 216 plus 60 minus 12 times 6, which is, oops, sorry, I forgot, this is 6 squared. I was like thinking that this is a negative number. 6 squared is 36, 36 times 10. So that is going to give us 360 minus 6 times 12 is 72. So we have negative 216 plus 360 minus 72. This is equal to 72. So up here it tells me that the profit in tens of dollars. So since the profit is in tens of dollars, the profit, max profit, is 10 times 72, which is $720. Okay, so that whole problem, A and B together, was worth 10 points. The first part, A, that is worth 8 points, and the second part, B, is worth 2 points. So number 2 says, answer the following questions about the function given information about the function derivative and second derivative. So part A says f prime of x is greater than 0 on the interval from negative infinity to negative 3 and negative 3 to 2. What does that tell us about the graph of f of x on those intervals? So I'm not going to write this down, but this is, well, I will. It tells me that f of x is increasing on these intervals. So if f prime of x is less than 0 on the interval 2 to infinity, what does that tell us? This tells me that the function f of x is decreasing there. The double derivative is greater than 0 on the interval from negative infinity to negative 3, 4 to infinity. This tells me that the function it's greater than 0, so it's concave up there. The double derivative is less than 0 on the interval from negative 3 to 4, so it's concave down there. F prime of 2 is equal to 0. What does that tell me about f of x? Well, it's a possible, and I can see later when I start to graph this, max or min. Of 0 at x equals 2. There's an inflection point at 4,3 on f of x. What is happening to the graph at the point 4,3? Well, inflection point means that it's changing concavity. At the point. So use the information given above and the rest of the following information to sketch the possible graph of f of x. So we're given that we have an x-intercept at negative 2, a y-intercept at 4. It's continuous and differentiable everywhere except at x equals negative 3, where it has a vertical asymptote and it has a horizontal asymptote at 1. Okay. So A, B, C, D, E, and F each are worth 1 point each. So that's 6 points right there. G is going to be worth 4 points. So it told me that we have a vertical asymptote at negative 3. So I'm just going to put a dotted line there to represent that. We have a horizontal asymptote at 1. So I'm going to put a dotted line there. We have an x-intercept at negative 2. We have a y-intercept at positive 4. We know that when x equals 2, we got 0. That was a derivative. Let's see. So let's look at where it's increasing. So we're increasing from -3 to 2, or negative infinity to -3. So on the left of our vertical asymptote. So let's look at that piece right now, and it tells me that it's concave up there. So I do not have a x-intercept on the left of this vertical asymptote. I know I can never cross a vertical asymptote, so I can tell that it could look like this, increasing everywhere, but hugging this line y equals 1. It's decreasing from 2 to infinity. So it's going down. I know it has to, it's increasing, let's see, from -3 to 2. So it's passing here, this x-intercept, it's passing this y-intercept, it's increasing, and it tells me that it's less than 0 from -3 to 4. So it's concave down. So increasing, concave down. Like that. It's increasing though until we get to 2. We know that the slope there is 0. And so it looks like it's a max there. We're decreasing from f prime 2 to infinity. But when x equals 4, we're changing concavity. It's going to start to be concave up. So right here at 4 somewhere is going to be concave up, but still decreasing. And we have a horizontal asymptote at y equals 1. So it's okay that the graph crossed a horizontal asymptote. It will never cross a vertical asymptote though. And so your graph should look something like this. Problem number 3 says, use implicit differentiation to find the equation of the tangent line at the given value of x on the following curve. Y to the 4th times the quantity 1 minus x, in your parentheses, plus xy is equal to 2 when x is 1. So we want to find the equation of a tangent line. We need two things. We need a point when x is 1, and so we need to plug this back into our original equation and solve for y. So we have y to the 4th, 1 minus x, which is 1, plus x, which is 1, all times y is equal to 2. Well, 1 minus 1 is 0 times y to the 4th is 0, so we get y is equal to 2. So we have a point at 1, 2. So now we need to find the derivative when x is 1, and so we're going to use implicit differentiation. Before I start my implicit differentiation, I'm going to distribute this y to the 4th, just so I don't have to use the product rule, although I am still going to have to for part of it. But y to the 4th times 1 is y to the 4th. Y to the 4th times this minus x is minus xy to the 4th, plus this xy is equal to 2. So using implicit differentiation, taking the derivative of y, well that is, y is a function in terms of x, so we have to use a chain rule. So bringing our power down front, we have 4y cubed times the derivative of the inside, so we're going to write it as dy dx. Minus, so here we're going to need to use the product rule, both pieces. And so the product rule says take the derivative of the first. And so the derivative of x is 1 times the second, y to the 4th, minus, because of this negative out here, x times the derivative of the second. So the derivative of y to the 4th is 4 times y cubed. But this is a function in terms of x, so we have to put dy dx here. is equal to the derivative of 2. Well, derivative of constant is 0. So we want to have all the terms that have dy dx on one side of the equation, and we want to get everything else to the other side of the equation. So let's add this y to the 4th on the other side, and at the same time, let's factor out this dy over dx from the other two terms. So pulling out dy dx from those other two terms, we're left with this 4y cubed here, minus, and then we're left with this x 4y cubed, which is equal to, and then adding this y to the 4th to both sides of the equation, y to the 4th. Let's divide both sides by that bracket, and so doing so we get dy dx is equal to this y to the 4th all over the quantity 4y cubed minus x, well, let's write it as 4x, y cubed. And so we want to find the derivative of this, and we have our point. We know that x is equal to 1, and our y value here is equal to 2. So going in here, we're going to go back in and substitute in what we have for y and x. We have the derivative at the point 1, 2 is 2 to the 4th all over the quantity 4 all times 2 cubed minus 4 times our x value, which is 1, times y cubed, so 2 cubed. So let's simplify. 2 to the 4th gives us back 16. All over 2 cubed is 8. 8 times this 4 is 32. Minus, so 2 cubed here is 8. 8 times 4 is 32. Something happened. Look back. Okay, so I realized back up here that when I went through, I did not do the product rule or differentiate this x times y. And so let's do that. If we do the product rule and we differentiate with respect to x, we should have a plus 1 times y plus x times the derivative of y, which is 1 dy dx. Now this is equal to the derivative of 2, which is 0. So over here, when we factor out the dy dx, and this one also has a dy dx in here, and so we're going to have a plus an x here when we factored it out. It's going to have a plus x here. When I divide it, is equal to, we added this y to the 4th to both sides, so there's the y to the 4th here, but we also have to subtract this y here, so minus y. So there should be a minus y up here. So minus a y, so we're going to add a 2 in here, minus 2, and then we divide it by plus an x, so plus a 1. So plus a 1 minus a 2. So my denominator, I have 16 minus 2, which is 14, all over 1. So I know my slope of my tangent line is going to be 14 at the point 1, 2. So y equals mx plus b, we can plug in our slope, our point and figure out what b is. So I know 2 is equal to 14 times x, which is 1, plus b. So b is equal to 2 minus 14, which is negative 12. So the equation of the tangent line, you should have had y is equal to our slope 14 times x plus b, which is minus 12. So this problem here was worth 10 points. Problem number 4. A school would like to enclose a separate play area for the kindergartners. One side of the area will be against the existing classroom, with no fence needed for that side. Find the dimensions of the maximum rectangular playground that can be made out of 900 feet of fencing with the remaining 3 sides. What is the maximum area of the playground? Okay, so we have some sort of a classroom right here. And we're going to put in some fencing. So maybe let this be our length, and we have 2 widths. So for our perimeter, we just need the 3 sides. And we know that we have 900 feet of fencing. So we have 900 is equal to the perimeter, twice the width plus the length. We're trying to maximize our area. And we know the area of a rectangle is length times width. So we want to have length, our area in terms of either just length or width. So let's solve for length in this constraint. And so length is equal to 900 minus 2w. So we're going to go in and we're going to replace what length is with this area. So we get the area is equal to our length, 900 minus 2w, all times the width. So let's distribute that w, and we get 900w minus 2w squared. So we're trying to maximize this, and so we want to take the derivative. So dA, dw, so the derivative of our area with respect to w is 900 minus 4w. We want to find our critical value, so we want to find when our derivative is equal to 0. So it's when 900 is equal to 4w. Divide both sides by 4, we get w is equal to 225 feet. We need to make sure that this is maximizing and not minimizing our area. And so we could take the second derivative. And if we do that, the derivative of 900 is 0 minus the derivative of 4w is just 4. This is always less than 0, so we know it's concave down. And so this is going to be always a max. This will be a max. So it's a max when w equals 225 feet. We need to figure out what our length is. Our length is equal to 2 times w plus, sorry, our length is not that. Our length is 900 minus 2w. So 900 minus 2 times 225. So 900 minus 450. Which is equal to 450. So the maximum area is going to occur when our length is 450 feet and our width is equal to 225 feet. what is the maximum area of the playground? So we can find the maximum area, right, by multiplying length times width. So 450 times 225. So that gives us 101,250 square feet. Okay, so that problem also is worth 10 points. And there's one more problem we need to go over. The last problem says x squared plus y, that quantity is all over the quantity x minus y is equal to 9, and dx dt is equal to 2. Then what is dy dt when x is equal to 4 and y is equal to 2? Hint, both x and y are functions that relate to time. So we need to use implicit differentiation here. I noticed that if I left it how it was, the equation, I would have to use quotient rule on the left-hand side. And so instead of having to use the quotient rule, we could multiply both sides by the denominator, x minus y, on both sides of our equation to clear the fraction, and then we won't have to deal with doing the quotient rule. If you didn't do this, you should get the same result at the end. So our x minus y's cancel on the left, giving us x squared plus y is equal to, and I'm going to distribute the 9, so we get 9x minus 9y. So now let's use implicit differentiation. This time when we use implicit differentiation, because our x is a function in terms of t and y is a function in terms of t, we need to use the chain rule in each case when we take the derivative. So derivative of x squared is 2x, but x is a function of time, so times dx dt, plus the derivative of y, which is 1, but that is also a function of time, so dy dt, is equal to the derivative of 9x, which is 9 dx dt, minus the derivative of 9y, which is 9 dy dt. We are going to want to solve for dy dt, so we want all the terms with dy dt on one side of the equation and all the other terms that don't have dy dt on the other side of the equation. So we have 1 dy dt. Let's subtract or add this 9 dy dt is equal to this 9 dx dt. And then we need to get this 2x dx dt to the other side. So this would be minus 2x dx dt. We can factor out on the left the dy dt from both of those terms. If we did so, actually we could have added those. This is really 1 plus 9, so that is actually 10 dy dt equals, I'm not going to factor it out here, 9 dx dt minus 2x dx dt let's divide both sides by 10, so we get dy dt is equal to 9 dx dt minus 2x dx dt, all divided by 10. So let's go back and substitute. We know dx dt is 2. And we're given x is 4. And y is 2. Well, we don't have any values of y left in here. So we don't have to worry about that. If we had used the chain rule, then we would have had values of y left in our function. So let's plug in what we know. We have dy dt is equal to 9 times dx dt, which we're given was 2, minus 2 times x, which we're given is 4, times dx dt, which again we're given is 2, all over 10. So order of operations, let's simplify the numerator. 9 times 2 is 18, minus 2 times 4 is 8, times 2 is 16, all over 10. So we get that that is equal to 2 over 10, which reduces down to 1/5. Okay, so that problem 2 is worth 10 points. You're going to want to go through, sum up the points for each of the problems that you gave yourself and put your score on the top of the test. And then you're going to scan that and upload it as a single PDF to the Canvas page. You want to do that before 8 a.m. on Monday, December 14th. I'll see you guys at your final on Wednesday, the 16th on Zoom at 8 a.m. See you guys later. Bye.